Hey, this is Mr. Frank, and today we are practicing our DESMOS graphing calculator and how we can do some of these regions problems just using the calculator. This is question number 26 from June 2022. Describe the transformations performed on the graph of f of x equals x squared to obtain the graph g of x when g of x is equal to x minus 3 squared minus 4. Sure, we're going to learn how to do this without the calculator, but today we're practicing with the DESMOS calculator. So the first thing that I'm going to do whenever I'm given functions, I'm going to enter them both into my graphing calculator. So I'm going to go right now to DESMOS, and I'm going to click in to the upper left part of my screen where I enter functions. I'm going to put f of x is equal to x. Now, if I want to add a square or an exponent of 2, I'm going to go down here. Sometimes it's hidden, so you might have to click this little triangle to show the keypad. And I'm going to look for where it says a squared. That puts a little exponent of 2 there. So now I have f of x is equal to x squared. Now, the other one was the g of x. I'm just going to put exactly what it is. It says g of x equals parentheses x minus 3, close the parentheses. And if I want to square that, I'm going to go down to my keyboard again and hit the square button, minus 4. And then I could see in purple the other parabola appeared. Now, I could also see here that, when I look at f of x equals x squared, notice that next to it shows a green kind of circle here. If you ever wanted to, for whatever reason, if you just click and hold that, you can actually change the color of your function. Right? I'm going to keep that red right there. You can also change how thick the lines are and whether they're broken or solid. Just a little note there, a little fun thing, and sometimes that's useful. But let's check my functions, make sure I have them both in there correctly, and I do. And now I'm going to look at my original, which is f of x equals x squared, and I'm really going to check out my vertex, right? The vertex is where it changes direction, and I can see in that original x squared, it's 0, 0. Now, if I say, well, what kind of transformation? How was this other parabola, the purple one, how did it move? Well, it moved. It's still kind of oriented the same way. It's still open upward, but it moved 1, 2, 3 units to the right and down 1, 2, 3, 4. Right? You can see that I can click right there, and the new vertex is positive 3, negative 4. So that actually tells me almost exactly what happened. So I'm going to go back here to this problem. It says, well, what happened? Well, describe the transformation. Technically speaking, that's called a translation, but I don't need to be that technical here. I can just say the g of x parabola moved. And if you wanted to be really technical, you could say translated, as you'll learn next year in geometry, 3 units to the right and down 4 units. And that right there is pretty much all you need to do. Without the calculator, one thing you might want to remember is that kind of this number that happens inside the parentheses is kind of the opposite of what happens. So if it says minus 3, it moves in the positive 3 direction. And this number outside really tells you exactly what happens with the y. It either goes up or down. So it's minus 4, so it's going to go down 4. And there you have it. I hope that was useful. This is Mr. Frank, and don't forget to subscribe to my YouTube channel.